Swayam Prabha. Digital India. Educated India.
Welcome once again. So, what we were doing, we were discussing about regression technique, right? Yesterday we were trying to understand using a simple diagram what is regression, and we have also discussed the OLS, ordinary least square technique, to estimate the population parameter alpha and beta. And today what we will do, we will take one data set and then we will try to estimate the model using a statistical software called Stata. But before we estimate the model, we will quickly recap what we were discussing yesterday, right. So, this is basically the regression what we are discussing. So, let us say this is our x in this axis, here we are measuring y, this is our regression line SRF, sample regression function, which is basically y I hat equals to alpha hat plus beta hat x I, sorry this is right x I. Okay. And then we say that for any given value of x, let us say this is x1, then your observed y I is, let us say here, this is y I, and then this is, let us say y1, but your model says this is your predicted value. So, that means this gives you the difference between this y I and y I hat. This is y I and y I hat is your error term, right, is your error term. So, that means this you can say that this is u1 hat. Similarly, for x2, let us say your observed y is here, but your predicted value is here on the line. So, that means this gives you u2 hat, y2 minus y2 hat, okay, right. So, then for this is for x2, and then for x3, let us say again this is your observed, this is your y3, but your predicted value is here, So, that means this gives you u3 hat, and again for this is x3, and let us say for again x4, this is your observed y, which is y4, but your predicted value is here. So, that means this gives you u4 hat. So, when your actual y is basically greater than your predicted value, then yi minus yi hat is positive. That means the predicted value of the error term is positive, but when your observed value is lower than what you have predicted, then your error term, predicted error value is negative. And then we say that here what we are trying to do, we are trying to minimize that ui hat square with respect to alpha hat and beta hat, right, alpha hat and beta hat. And then if you solve this, then what will happen, your beta hat what we have derived, beta hat is basically summation x I minus x bar into y I minus y bar divided by x I minus x bar whole square. Okay, this is your beta hat, right. Now, this is your beta hat OLS, because we have estimated this using by minimizing the sum of predicted error square. that is why it is called ordinary least square technique. Now, there are three important properties. There are three important properties about this beta hat, the way we have derived here, that we must understand and keep in our mind. So, three important properties of beta hat, or I will say these are the three important properties of beta hat. First of all, from the formula, beta hat equals to xi minus x bar yi minus y bar divided by summation xi minus x bar whole square, what we can understand that beta hat depends solely on sample observation. That means, if you know x, if you know y, if you have data on xi, if you have data on yi, then without knowing anything you can actually estimate your beta, because this is the beta hat formula. Only one assumption what we are making here, that the what is required solely on the observation, and what is required is expectation of ui given xi equals to 0. That is the assumption we need for the estimation purpose. So, once again I repeat that econometric analysis, it involves two stages. First stage is estimation, second stage is inference making. So, as far as estimation of beta hat is concerned, from the formula what we have derived, we can easily understand that it does not require any other assumption, anything else apart from knowing the xi and yi. So, only assumption about the error term what is required is expectation of ui given xi equals to 0, because when we are minimizing sum of ui hat square, why we are minimizing sum of ui hat square? Because sum of ui is 0, because this line is the average line. This line is the average line, and we said that expectation of ui, mean value of ui is actually 0. So, that is the assumption what is required for estimating xi, for estimating beta hat OLS, right. And no distributional assumption about the error term is required for this estimation purpose. So, that means the assumption that ui follows a normal distribution is not required for estimation purpose. Without knowing the distributional properties of ui also we can estimate beta hat. Distributional properties are required for the second stage of inference making, that is all. So, a beta hat depends solely on the sample observation. Then secondly, beta hat is called point estimate of the true population parameter beta. Now, why this is called point estimate? Because if you solve this, you will arrive at a specific value, let us say 0.75. Okay. So, that means if you know xi and yi, and if you solve this using this formula, then you will arrive at a specific value of beta hat. Let us assume that that value is 0.75. Since we are arriving at a particular value of beta hat using this technique, this beta hat so derived is called point estimate of the true population parameter beta. Now, this point estimate has, using point estimate for inference making. That means, in our entire econometric analysis, what we are trying to do, we are trying to infer or guess something about the true population parameter beta. That means, we are trying to understand the consumption behavior of the population using a sample. That means, from the sample we will get beta hat, and we are trying to use that beta hat to guess or infer something about beta. So, when beta hat gives you a specific value 0.75 and using a specific value to guess something about the true population parameter, it involves some amount of risk. Why this is so? Because from the given population, as I told you, that we can derive so many samples. In one sample I got 0.75, there is no guarantee that in the next sample also I will get a value like 0.70 or 0.80 or 0.65, which is significantly greater than 0 but less than 1, because this gives only one specific value. That is the risk of using point estimate. Even though it is easy to calculate, it is risky to use point estimate for inference making. Then what is required? Instead of using this point estimate, we will discuss and estimate the other type of the other estimates of beta, which is called interval estimation. So, instead of giving a specific value, we will say that this is the range in which the beta hat may lie. Okay? So, that is called interval estimation. We are not discussing interval estimation right now. We will discuss interval estimation when we will discuss hypothesis testing, but for the time being, you have to keep in mind that this is point estimate, and what is the risk of using point estimate for inference making, because there is no guarantee that in all other samples derived from the same population, your point estimate of beta will emerge like a value which is significantly different from 0 but less than 1. This is property number 2. This is called point estimate. And property number 3, it says that the regression line passes through the sample mean. What does it mean? That means, if this is your x, this is y, let us say this is x bar, y bar point, this is y bar and this is x bar. Okay. Right. So, your regression line, estimated regression line must pass through the sample mean x bar and y bar. This is also an important property of the sample regression function, you must keep in mind, and this property would be useful later on. Okay. Now, after this, what we should know, now we will go back to the regression we will learn regression. We will use a data set and we will regress yi on xi to get your beta hat. But before that, I would like to make you I will remind you about the objectives of a regression analysis. Objectives of regression analysis. So, when you are estimating this type of model, yi equals to alpha plus beta xi plus ui, the first objective of the regression analysis, as I have already mentioned, that regression analysis is also known as dependence analysis. That means, we are trying to analyze how this yi is dependent on xi. yi is dependent on xi. So, that means alternatively we can say that the objective of regression analysis is to explain the variation in y with the help of variation in x. So, what I am saying, first objective is to explain variation in yi, which is the dependent variable, variation in yi which is the dependent variable with the help of variation in xi, which is the independent variable. Okay. Now, when I am saying explain the variation, that means this is basically variance I am talking about, and variance is always defined as a deviation from the mean. So, that means you can say that objective of the regression analysis is to explain the variation in y around its mean value, variation in yi around its mean value, that means yi minus y bar. Okay. This is the variation or variance, variation in yi around its mean value, that you are trying to explain by the variation in x. Okay. That means with the help of the explanatory variable. That is the first objective. And secondly, to predict the value of yi, which is called yi hat, for a specific value of xi. That means you will estimate this type of model, yi hat equals to alpha hat plus beta hat xi. So, if you know your alpha hat and beta hat after estimation, then you can predict yi hat when you put a specific value of x, right. So, these are the two objectives of regression analysis. And I would also like to remind you that regression analysis is also known as regression analysis is also known as analysis of causation. Analysis of causation. Okay. So, that means I would like to estimate some causal relationship between yi and xi. How will you do that? This is our model. So, if your beta hat turns out to be significant, that means significantly different from 0, I can say that x actually causes y. That means income can explain the variation in consumption. That is why it is also known as causal relationship. But econometric analysis per se will not tell you the direction of causation. That means here you have specified yi as a dependent variable, specified xi as an independent variable. That is why when it is significant, I am saying the causation runs from x to y. But it is you who are specifying y as your dependent variable based on your own knowledge or existing theory. So, that means this analysis is not telling anything about the causation, what should be your dependent and what should be your independent variable. That you have to keep in mind, that it is you, it is the researcher who is specifying the dependent variable and independent variable, and after estimation by looking at the significance of this coefficient beta hat, you are telling that yes, the causal relationship is established, but it was you who actually hypothesized. You only hypothesize the causal relationship. Econometric analysis is only telling you whether the causal relationship what we have hypothesized earlier, that is established or not, that is all. Okay? So, this is known as analysis of causation, and one related concept if you might have heard called correlation. So, there are two types of two concepts, related concept. One is called causation or regression versus correlation. So, regression analysis, as I told you, this is causal relationship or causation. Regression is also known as causation. But in correlation, no causal, no causation. Only degree of association. Degree of association. For example, if I look at the smoking behavior of individuals and cancer of individuals, cancer patients, then correlation will tell you whether smoking behavior has some kind of association with cancer, but I do not know whether smoking is actually leading to cancer or not. Say another example, let us say I have collected a student's score in mathematics and statistics. Then the correlation analysis of mathematics score and statistics score can tell you whether there is some kind of degree of association between the math score and stat score, but I do not know whether math score is leading to stat score or stat score is leading to math score, that I do not know. So, that means while regression is called a causal analysis, correlation can only tell you the degree of association, nothing more than that. That is the difference between the regression and correlation. So, with this, now what we will do, I will now going to introduce the statistical software, and I will now show you how to estimate the model which for which you might be eagerly waiting. So, look at this first. This particular software, this is known as STATA, S-T-A-T-A. This is a software that I am going to use throughout my course. So, you have to get an access to this particular software STATA. Of course, the estimation is possible in other softwares also like R or MATLAB or SPSS or any other software, but the only thing is that I am going to demonstrate throughout this course of basic econometrics using this particular software. So, it would be really helpful if you can manage this software. Otherwise, you have to estimate using the other softwares for which I am not going to give you the demonstration. Right. So, the alternative softwares for this estimation purpose is SPSS or R, MATLAB and eViews. eViews, SPSS, R, these are the statistical software. MATLAB is of course is not a statistical software, but with that also you can do it. Okay. So, since I am going to use this software, it would be helpful for you if you can manage to get an access to this data. Now, I will show you what is my data source, what is the data here that we are going to estimate. Look at this. This is a hypothetical data, small sample on consumption and income for some 10 families. So, I have a simple data of income and consumption. If you have data on 100 families or 1000 families, the technique what we are going to learn is same. So, if you learn the technique of estimation using this small software, you can use it for a large data set also, absolutely no problem for that. And I am going to share this particular data set also with you, so that at home if you have access to data, then you can actually estimate the statistical model. So, in this you see there is a this window is called command window. That means whatever you would like to estimate, you have to specify a command for that, and all these commands, how to estimate a model using data, all these commands are easily available online. That is why I said earlier that estimating a model is not at all difficult. It is very simple with the advent of statistical software, but what is more important is to know the theoretical stuffs of econometrics, so that after estimation you can actually interpret the coefficients. Okay? So, that means for interpreting the coefficients you need to know the theory, and for command and other things you can simply type in Google and Google will help you giving all sorts of commands what is required to perform any type of statistical analysis using data. Okay. So, it would be good if you can remember or you can write it down. This is a simple command for estimation. So, the command what I am going to write is reg for regression, then you have to give you one space, and then you have to specify what is your dependent variable. In this example, the dependent variable is consumption. So, if you double click on consumption, it will automatically take, you do not have to type here. Rather, you should avoid typing, because while typing if you make any small mistakes also, then data will not take that command, because the variable is already defined in this way, then your independent variable. So, this is how I have given a command for estimating the model. So, I have given reg command, then after that my dependent variable, and then my independent variable, and now if you put enter, then data will immediately estimate the model and give you the result. Now, I have got so much of result, but I do not know how to interpret, right. Now, look at step by step. Come to this table. See, here they have mentioned consumption, which is basically your dependent variable, then they have mentioned coefficient. I am not going about the standard error and other things for the time being, because those things I have not discussed and you will not be able to understand also. So, coefficient, and after that they have given your independent variable, which is income, and what is the coefficient of income? 0.50. So, that means the model what we have specified yi equals to alpha plus beta xi plus ui, the estimate of beta, that means beta hat is 0.5090. And what is alpha hat? Alpha hat is actually 24.45. So, this much we know. So, data is immediately giving you the estimate of alpha and beta. Alpha hat, the constant term, is 24.45, and the beta coefficient, beta hat, is 0.5090. Fine. Now, the question is, how do you interpret this coefficient? As I told you, the interpretation of this beta hat is very simple. It says for a unit change in income, when income changes by 1 unit, your consumption changes by 0.5090 unit on an average. On an average. Again I am telling you, this on an average is very important, because this interpretation is valid only for the average individual. That means, if the individual is having income with sample mean, then for that individual, when income changes by 1 unit from the sample average, then your beta, your consumption changes by 0.5090 unit, okay, and that is also from the average, because first of all you need to take expectation of y given xi, otherwise you cannot remove your ui. So, I will just show you what actually you are getting. You are getting when your yi equals to alpha plus beta xi plus ui. First thing what you are doing, you are taking expectation of yi given xi equals to alpha plus beta xi, because expectation of ui equals to 0. So, if you differentiate this, then delta yi given xi equals to, that is why the beta hat after estimation, what does it say? It says for a unit change in xi, what is the change in this expected value? That means the mean value. That is why I am saying that on an average concept is so important. Without that, your interpretation would be wrong. So, that means from this 24.45 and 0.50, I can easily draw the diagram also. This is x, this is x, this is y, and your regression line is this, where this is actually your alpha hat, which is equals to 24.40, and this is actually your beta hat, which is 0.5090. Okay, this is the interpretation. So, beta hat actually gives you slope of your sample regression function, and the other name of beta hat, as I told you earlier, it is basically MPC, marginal propensity to consume. When your income changes by 1 unit, what is the change in your consumption on an average? That is called marginal propensity to consume, and that is what is called beta hat. Okay, 0.5090. So, from the output what Stata has given, only this much we can understand, but there are so many other things that are given by Stata. Let us now try to understand those things. Now, once you estimate the model, that means what basically you are doing? You have a raw data on your y and x. So, that means this is your, let us say, scatter plot, this is your scatter plot, and you have fitted a line to represent your data. But I do not know how good is this line, how good is this line to represent your data. So, that means I need to know something about the goodness of fit for the model what you have estimated. Why that is required? I am repeating once again. If you plot your raw data of x and y in Excel or any software and ask the software to give you a scatter plot, this is the scatter plot, okay, the relationship between x and y. Now, this line basically regression line is going to represent that scatter plot, right. So, once you fit a line, I can fit any line, right. Instead of this, I can fit this line, I can fit that line, many line I can fit. So, once you fit a line, then you have to then tell me, alright, you have fitted a line to represent the raw data, the scatter plot, but how good is this line? How good is this line? So, to know that, I need to know the goodness of fit, goodness of fit, that is what is required. Let us now try to understand the goodness of fit using a simple diagram. We will first understand that, and then we will go back to the Stata result and interpret.